So these notes today, this is about size of atoms. So quick reminder first, what is an atom? Little piece of stuff, makes up all kinds of things. What do we call them? Where do we find them? Element. They're elements, right? So the first thing is the technical term for size of atoms is atomic radius, which atomic means atom, right? And radius means the distance, like we've talked about this before, right? Like this is the really super basic version of an atom. And so the electrons go around on the outside. And so the radius that we're actually measuring is that distance from the middle to the outer edge. Sound good? But it just really means size. Okay? So the question here is, here's a periodic table just to look at really briefly, which, by the way, you will have a periodic table like this one on the test. Pretty basic, doesn't have a lot of stuff on it, but you'll have a blank copy of like this on the test. Where do you think are the larger elements on here? Probably near the bottom. Why do you say that? Because why? No, that was sensible. What did you say? They're heavier. And being heavier means they have more what's in them. More what? More mass. But because they have more mass because they have more... What is the atomic number? What does that mean? The number of protons, electrons, and neutrons. And that specifically the atomic number refers to the number of protons. And then right now in this course, it also is the number of electrons. It won't always mean that, but for now it does. Okay? For now, we always have the same number of protons as electrons. Very soon, we will not have that situation anymore. So, but yeah, more of them toward the bottom, right? This hydrogen has just 1, lithium has 3, sodium has 11, right? Like it gets more as you go down. It also means that as you go further down, you have more electrons, and therefore they kind of spread out more from the nucleus. So, 2 things to know about the size of atoms. Bigger elements are at the bottom. All right? And what this really means is that they have more, like we said, protons and electrons. Oops, that's not how you spell protons. All right? And specifically, electrons end up being more important than you think. Because did you know that if you were to blow up an atom to be the size of a football field, anybody want to guess how big the nucleus would be? If you were to blow up an atom to be the size of a football field, how big would the nucleus be? You want to take a guess? A blueberry. Great guess. Anybody else want to guess? Anybody think, wow, that's stupid small? It actually is the size of a nickel, which is really close to a blueberry. So good guess. You must have heard that analogy somewhere before. You really just guessed that out of nowhere? Good job. So the place where the protons and the neutrons are is the nucleus, and it's super duper small. They're crowded in there like crazy. A lot of interesting questions there we're not talking about. The electrons is what takes up most of the space of an atom, right? Because they're going around in circles around outside like this, right? So what ends up happening is that each row, which we call period, okay, that's just kind of the term for it, has more rings of electrons than the above one. Does that make sense? So like over here, hydrogen has just one ring of electrons, lithium has 2 rings of electrons, sodium has 3 rings of electrons. Does this make sense? And of course, the rings get bigger as they go out, right? So can you see why that makes the atomic radius get bigger? Does that make sense? Shake your heads, guys. Come on, help me out here. Okay? So there you go. And then the next question is, can I cover this up for a second here? You guys good? Let's take a couple of these. Let's talk about lithium and fluorine. Which one of those do you think is bigger? Look at the number of protons and electrons. Fluorine should seem like it should be bigger, right? You know what? It's actually not. Does that sound crazy? So the bigger elements are at the left, which is super surprising. All right. And there's a lot that goes into this, which we're kind of going to just barely touch on today. But I'll kind of give you the idea for why. Okay. So here we go. Let's draw lithium. Here's the nucleus of lithium. How many protons are in a lithium? 3, because the atomic number is 3, right? That means that it has a charge of 3+ in its nucleus, right? Because protons are positive. Shake your heads. Yes, protons are positive, right? Okay. So it also means that it needs to have 3 electrons. There are 2 electrons in this inner layer. Just trust me. And then the third one is out here by itself. Sound good? Now let's talk for a second about fluorine. Let's draw fluorine. So here's fluorine. Here's its nucleus. How many protons are in there? 9, because it says 9 right here is the atomic number. So this one is 9+. Okay? Like us, the same situation here. The first 2 electrons would be in the middle, in the inner layer, in the first ring. And then this next outer one here can fit the remaining 7. So 1, 2, 3, 4, 5, 6, 7. That's just how it is. Trust me, we'll talk about it more another day. So what happens is this charge right here is 3. And this distance between here and here is roughly the same as this distance between here and here. Do you see that? Like, because of like the number of rings, like it's kind of like how many steps out did we have to take? Well, we took 2 steps out with both, right? 2 rings out, right? Am I making sense here? Shake your head so I know I'm making sense, okay? So because you took kind of like roughly the same distance out, but look what happened to the amount of the positive charge. Because positives and negatives attract each other, right? Because opposites attract, just like magnets, right? Which nucleus is pulling harder?
The right one.
9 is pulling way harder, right? So what actually ends up happening is that these right here get pulled inward harder than this one gets pulled inward, like gravity, right? Which of the planets comes closer to the sun? Right? It's kind of the same deal there. All right. So what that means is that the elements at the left have less strong of a pull on the outer ring of electrons. Does that make sense? So the right side elements, electrons, that is not how you spell electrons. Electrons. Get pulled in tighter. Does that make sense? So it ends up being different than what you expect, that the bigger elements are on the left side of the periodic table. Cool?